All right, so let's just jump into this. The first thing we're going to look at is rotation range, and all that is doing is rotating the image along its axis based on the value that you give it. So here we give it 50, and that would just be 50 degrees of random rotation. So each iteration and each new image that it creates will randomly pick from 0 to 50 degrees as far as rotation transformation, and it will then save the new image. Pretty simple. So let's go ahead and take a look at that right now. Okay, as you can see, we produced some nicely rotated images, and you can quite easily imagine scenarios in which this would be extremely helpful, right? You know, a person who is upside down, hanging upside down from a tree. If every single image that you have is of a person in a normal posture, maybe just a slight angle with the face, your neural network is going to learn that class this way from that perspective, right? So it's only going to learn that a person stands straight up or sits straight up and faces the camera directly or with a slight angle or what have you, whatever the perspective is, right? So, well, in general, you should have, a series of transformations that you apply normally on your data set. There are some others that can be helpful in, particular situations on which you have some sort of an idea or a guess as far as, why this would be helpful or why the perspective would be changed in this way. All right, so let's clear those out. Okay, and going back to this, our next one is going to be width shift range, and all that is going to do is transfer the image across the x-axis, so to the left or the right, and this is one of the less intense transformations and probably one of the lesser beneficial, just because it's not doing too much to the actual features in the image. The same with the horizontal shift, but you don't always know the variation of the images you're going to have at predict time. So it doesn't hurt to do something small like a width range shift of 0.2, as you'll see. It's not anything too crazy, and that will just be sampling randomly 20% of the width of the image left or right. Okay, we'll take a look at a few of those. So as we can see, that one shifted to the left. This one doesn't shift much at all. This one shifted to the left again. Well, maybe those are shifted to the right. Oh yeah, seemingly those are shifted to the right. Okay. Let's get rid of those. Okay. The next one to cover is just height shift range. And as I said before, that is just going to shift it along the y-axis vertically, up or down. Let's take a quick look at that. You can see the vertical perspective is slightly changed. All right. Get rid of those. All right. So next we have shear range, and this is quite a fine transformation. You can see that I'm increasing the value compared to the previous two quite a bit. it's probably best if I just show you for this one, because it's a bit hard to explain the actual transformation. It's a shear angle transformation, and you'll see what that means. And it may not be super clear, but as I go through these, just try and see what changes. Right? So it's almost as if you are rotating the pixel slightly around the axis. That's not a, true explanation of what's going on, but it's an analogous example, and it's hard to explain otherwise, but this is mostly used in conjunction with other transformations. You wouldn't normally use this on its own. Okay. All right, next is zoom range, and as you can probably guess, it is how much we are going to zoom on the image. Same with all the others, it's a percentage of the total dimensionality of the image. Okay, let's take a look at this. And it can obviously also zoom out. There you go. Pretty simple stuff. Okay, next is horizontal flip. And that is going to be precisely as it sounds. Horizontal flip is going to randomly flip it across its horizontal axis. Not much more to say than that. As you can see, not all of them are flipped. Sorry, it's across the y-axis. It's a horizontal flip, so it's across the y-axis. Not across the horizontal axis. Yep, so just a 50-50 random whether or not it flips across the y-axis. And we'll quickly, before we go into channel shift range and vertical flip, we will just, and rescale, we will quickly look at vertical flip. Because as you can guess, it's just a flip across the horizontal axis. Right, and I'm sure you can think of many different ways in which this would be, quite helpful. For example, this would be great if, you normally have perspective, which is, face forward, and you imagine that the human class that you're working with could have, any orientation as far as the human in relation to the background and the rest of the scene. Vertical flips, horizontal flips would help with learning those different perspectives. Okay, so channel shift range. What this is a shift across the color channels. So you can think, for example, a shift from RGB to CMYK, that would be a channel shift. But of course, we're not going to do that type of shift range because we're sticking with RGB and just shifting across those three axes. And we'll just do a 0.2 value. And this is a really interesting transformation, especially if you're working with, a lot of the time you may not have to use or worry about things like color. You're just trying to identify an object, and for the most part, objects aren't related to their color, but there are many examples in which the object that you're trying to, or the class that you're trying to figure out is actually related to the color. But in this case, if you are also doing, for some reason you want to work with color photos, and you're not absolutely sure the color of features that are going to pop out, this would be a great thing to use. Okay, let's flip these. This one is very subtle too. Super subtle. Yeah, maybe just the value that I had for the channel shift range, but that's what channel shift range is going to end up doing, is just changing the color channels. And then finally we have Rescale, and that, again, most of these are pretty simple as far as figuring out what they're actually doing. Just rescaling the photo. I'll just set that at 0.5. It's also going to be random rescalings within the dimensionality of your data. It's pretty straightforward. Most of these, all the values in the image data generator will have to do with the dimensionality of your image data, with exception of things like rotation range and vertical flip, which will be the same regardless of your image dimensionality. Okay, so that'll do it for this section. I'm going to go over a little bit more, and then we will have another example to finish up this lesson.